Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question extracted from 2018 Time Zone 0 in November. Question number 17 relates to the topic 15, a lot about definitions within the topic of energetics. Let's see, they're asking which change is going to be exothermic. So keyword here, exothermic. So you are going to find out one reaction in which the delta H is going to be negative, right? So obviously you are given four choices, each with a solid definition behind that is meeting actually. So let's see. For A, as you can see, from half of the moles of the chlorine molecule now break down to 1 mole of chlorine atoms. Basically, this is actually what we call atomization. Right? Or you can say the bond enthalpy that is now overcoming, right? Because now you see the bonds are now being broken back to the gaseous state atom. So you can say this is also relates to the concept of bond enthalpy, ALPY, right? And so the energy is always be required to break the bonds, in terms of this case, the covalent bonds of the Cl-Cl bond. So remember, breaking bonds is always to be endothermic, right? So that's why obviously not the choice of A, right? So let's continue. For B, from potassium to a gaseous state of potassium ion that with 1 electron being taken away. So obviously this is what we call the ionization energy. Ionization energy. And remember, from the definition, energy is required in order to remove 1 mole of outermost shell electron from 1 mole of the gaseous state atom, 1 mole at a time. So obviously also to be endothermic, so not our choice. For C, from potassium chloride down to potassium ion and chloride ion with the gaseous state condition. So this is meeting the definition of lattice enthalpy, LPY, right? What's lattice enthalpy again? Energy required to break down 1 mole of solid ionic compound back to gaseous state ion. So again, energy is required. So that's why not C again. So obviously our best choice would be D, but let's check. What is D? It's going to be chlorine atom now accepting 1 mole of electron to become 1 mole of gaseous state ion. So this is exactly what we call the definition of electron affinity. And mind you, for the electron affinity, the first electron affinity will be going to be exothermic, because when the first electron is being accepted, it is due to the attractive force from the nucleus that having a certain effective nuclear charge in accepting or attracting these electrons. So that's why after the acceptance, it will be becoming a chloride ion. So obviously in this case, it is going to be welcome to do so. So energy is going to be released. So that's why for electron affinity, the first EA must be exothermic. So that's why answer is D. So mind you, one more thing is that although not asking this time, starting off with second EA and so on and so forth, then the exothermic component will be now switched to the opposite side of endothermic. And the reason behind is kind of easy, because after accepting the first electron, everything now becomes a negative charge. If you ask a negative charge species to further accepting something that is negative electron, that is going to be not so easy. So that's why for electron affinity from the second and so on, energy starting to be endothermic. But remember, the first EA is always going to be exothermic. So answer D.